Hello class, in today's lecture video we're going to cover some examples related to our most recent section on angles. Namely, we're going to look at the following three types of problems. First up, plotting angles in the radian measure. As you can see on the board, the first one is prepared and ready to go. And then we're going to do some examples involving coterminal angles. That is to say, two angles that are different in their numerical size, but they correspond to the same geometric image after rotation has been completed. And finally, we're going to go into some conversion examples. That is, if you have an angle in degrees, you should know how to convert it into radians and vice versa. Okay, so then without further ado, our first problem up on the board is as follows. Plot the following angles, and all of these are assumed to be in the radian measure. Okay, so first up is 7 pi over 6. So one of the things that we could do, other than just rote memorization, is recognize what we mean by this fraction and how angles go together. So to say 7 pi over 6 can be thought of as 7 multiplied by this, or in other words, it is 7 rotations of the base angle, which is pi over 6. And pi over 6 is one of the angles that you need to know and memorize. Pi over 6 has the magnitude of 30 degrees. So that could structure my thought or my work that if I were to do 7 copies of this rotation, I could begin, for instance, over here at something that looks like a 30-degree angle. That would be 1 rotation of pi over 6. And then if we go again, a 30 and a 30 is 2 copies of pi over 6, which is pi over 3, another angle that we should know about. And I can continue in this way because 3 rotations, 4 rotations, 5, I could count step by step. Or another way to do that same thing is to see that, well, 7 copies of pi is, all my markers are studying when I started the film. 7 is also 6 copies, and then 1 more copy. In particular, 6 divided by 6 is pi. So do 6 of those rotations first, and then do the 7th one in this way, so that 6 of them brings you over to pi, and then 1 more would be the 7 pi over 6, which is just a 30 angle progression down below. So then the full sweep out would look like that, and we would erase our markings that allowed us to think through that structure. But that's the angle of 7 pi over 6. Namely, magnitudes in the numerator should be interpreted in most cases as a number of rotations of something base that we just crank around. Okay, so with that being said, we could do the same for B, and then I'll erase the board for the first two. We want to recognize that negative 3 pi over 4 has this basic structure within it. It is a 45-degree angle, but the minus sign means that we rotated backwards. Or in other words, to get 3 copies of pi over 4, that's the same thing as to do that negative rotation once, and then a second time, and a third time. And every time you see a subtraction or an addition, we would crank backwards or forward, subtraction or addition, and so we could just chunk along to get the right magnitude. So to rotate backwards 3 pi over 4 is to first go 1 copy of 45, and then a second copy would bring you here, and then the third rotation would swing you back through that main diagonal, and that is the angle rotation of negative 3 pi over 4. 45, a 45, and 1 more 45 twist in the clockwise progression. All right, so then moving on to part C. 3 pi, maybe you can see how to break this up. Essentially, 3 pi is to do a pi rotation and then another one, and just like the comments of knowing pi over 6 we're knowing the basic turn rotation of pi over 4 being a 45-degree angle. We should also know that pi corresponds to a full 180-degree rotation. So to do 3, we just count them off: 1 rotation, 2 rotations, and then continue on to the third. So we would revolve exactly once about the origin, and then 1 more copy of pi to have 3 pi plotted in that way. All right, so the final one is a negative rotation angle again. So we're going to spin backwards through quadrant 4. And what we'd like to do is visualize this as turning backwards by negative pi over 3, and then turning backwards 1 more copy of negative pi over 3, because we have 2 copies rotated in the negative direction. It's the same as negative 2 pi over 3. So the basic angle pi over 3 is associated with the 60-degree measured turn. So if 45 is right through the diagonal, then 60 is something below. And you could probably do 60 and 60 is 120, but we just have to remember to rotate in the right way. And so that would be the correct sketch of the angle negative 2 pi over 3. All right, so for our second example of this variety, we're going to do the following like we've done before. Hopefully you've seen previous videos, but I'm going to ask you to try this on your own. And that is to pause the video, and I'll do an edit. But after pausing the video, work on it. And then after the edit, I'll reveal the answers. 3, 2, 1, go. All right, so here's the reveal. Hopefully, looking at the solutions that you've written down, you have a match. But if not, just go ahead and review the thought process or reasoning that's suggested over here. The angle 5 pi over 4 is 5 copies or 5 turns of a magnitude of exactly 45 degrees. And over here, the negative 3 pi over 2, is to turn backwards 3 copies of 90 degrees. So 1, 2, and 3, as pi over 2 is a 90-degree turn, and the sign makes us turn backwards. And the reasoning that we could use here, other than just rote memorization, is 5 pi over 6 is pretty close to 6 pi over 6. That's just 1 angle rotation more than what I asked you to plot. It's as if we went that far, but we just stopped short exactly 1 rotation of a 30-degree angle, which would complete that to pi. So there is 5 pi over 6. All right, so we're up for our next problem model in the section, namely example problems dealing with coterminal angles. All right, so recall that coterminal or shared terminal angles are ones that look the same after plotting, but the measures that are used, whether it's degrees or radians, for alpha and beta have different numerical values. And the key equation behind determining whether angles are coterminal is just to recognize that the difference or the gap, the spacing, will always correspond to either 360 or 720 or negative, because we could rotate the other direction, negative 360. In other words, it's an integer multiple of 360 in the degree measure, or equivalently, multiples of a full revolution in the radian is 2 pi. So you're allowed to get 2 pi or negative 2 pi, or 4 pi, 6 pi, or negative 8 pi, but not 5 pi, because that is a full turn and then another half. So, making use of these equations or ideas, determine if the angle pairs given are coterminal. Okay, so then the solution method is the same for each. We just have to recognize whether or not we are making a comparison in degrees or we are doing this in the radian measure. So the easiest way to go about this is just to take the larger angle and subtract away the smaller angle to see if it is a multiple of 360. And here, if you subtract these two away, then you do in fact get 720, which is double of 360, i.e. to get from 35 to 755, we would plot 35 and crank around once for 360 and once more for 720. So we put a check mark. Yes, these are coterminal angles. They would have exactly the same geometric image, even though the magnitudes are off. Okay, so then turning to the next one, same structure. We're going to take the larger minus the smaller, and in that way, it'll always just appear to be a positive value. But if you do the subtraction here, you'll have 300, and then 25 off of 75 is 50. And so we arrive at 350, but 350 is not 360 or a multiple of it, so they are not coterminal. One would be off from the other by 10 degrees. Okay, so likewise over here and here, we're just now thinking in the system of radians, and we could do the same, larger minus smaller, and just see if it's a multiple of 2 pi. So 8 pi over 3 minus, right, I've been subtracting throughout, but minus a negative, minus minus becomes a plus. So take care there that when we subtract a negative, well, first that we're always subtracting here, but that changes the sign. So then 1 and 8 become 9. 9 is divisible by 3, but 3 pi isn't 2 pi, or 4 pi, or an even multiple of pi. So no, we're out, they're off. No, not coterminal. Okay, so then the final example here, I've in the first three, always arranged it large, small, but it doesn't have to be. If you look at these two values, which one's actually larger? Well, this one is closer to 0 than this one. So then larger minus smaller would be negative pi over 4 minus becomes a plus. And then taking the 2 in that way will guarantee that we get like a positive magnitude out. So minus minus is a plus. So we have positive 9, but minus 1. So the numerator comes out to be 8 pi over 4. And yeah, this one actually works because we got dead on the nose, a full copy of a revolution in the radian measure, 2 pi. So we would report yes, coterminal. There you have it. All right, so here is our second and then final problem model involving coterminal angles. Namely, you could be asked to find two coterminal angles, one positive and the other negative for the given values. Okay, so the solution is definitely non-unique, but the idea is that we need to add copies of 360 as many times as required in order to produce a new coterminal angle that's different than this one. And likewise, we might have to rotate backwards by a certain number of magnitudes in order to find one that's coterminal but negative. So because 400 is large, to find a positive working example, sorry, my 0 looks like a 6, all I need to do is add on one full revolution, 360, to arrive at 760, and I could use this as my positive coterminal angle. But now notice if I reverse direction, in order to get negative ones, I would have to go backwards. That if I just simply subtracted one copy of 360 off of 400, it is not a negative one yet. It's positive. And as I said at the start, the values that you give are not unique. This also would work as a positive coterminal angle because it is a backwards rotation to a positive value that would look the same. But in order to produce the negative one, we would have to take this value and crank backwards one more time to come up with negative 320. And by the way, if you just saw at the start that one copy of removing 360 did not produce a negative, and you just happened to see at the start that this would result in our answer, that's fine as well. So there is a negative and a positive, or a negative and a positive coterminal angle for the first one. All right, so likewise for the second one, all we're going to do is add on multiples possibly of 2 pi or subtract away multiples of 2 pi to produce new angles that are either positive or negative away from the first one here. But now the only thing that needs to be said and done, that say for instance when I add 2 pi, we have to work with the common denominator, and here that would be 7. So then 7 over 7 gives us 14 pi over 7. So a solution is 13 pi over 7. That's a positive number, so that works for us. And then for the reverse direction, we would crank backwards by 2 pi, but we've already done that work. 2 pi with the common denominator works out to be 14 pi over 7. So then negative 15 pi over 7 is a coterminal angle to negative pi over 7, and there's one that's positive and one that's negative, and that's how you answer these problems. For our last problem, we're going to look at the following. That is, we've been asked to convert the given values, if stated in degrees, to radians, or if the given value starts in degrees, convert that to radians. Okay, so the key multiplicative factor, depending upon whether or not we're going from one system or the other, is to use the fact that 180 degrees is worth the same magnitude or amounts as pi in the radian measure. So we're going to use these as ratio values to scale up or to scale down, depending upon the given starting quantity, that is the unit measure. So this one here, we have 135, and that's starting in degrees. But if I want to convert to radians, we need to use the second ratio, because in the denominator, we use 180, but the degrees need to cancel, and pi is implicitly in radians. So it turns out that that happens to be 3 copies of 45, and then pi. So that factors there. And 180 works out to be 4 copies of 45. And so 45 and 45 cancel, and then this works out to be 3 pi divided by 4. Okay, so for the second one, there's 2 things that you could do. We could do it exactly like before, namely we have 540 degrees, so we need to stack our equivalent ratio in the following way. The degree measure needs to sit below, so cancellation occurs, and then maybe you could see that there are 3 multiples there. But also an alternative path is to recognize that 540 is the sum of 360 and 80. And again, check it. 8 and 6 give me the 4, carry the 1, 5, because it's 1, and the 1 that's carried in 3 is 5. So then this would be 2 pi, and 1 more is 3 pi. So it could be done in that way for this problem. All right, so for C, we have a starting angle that's in radians. So we're going to want to turn to this stacking because we'll want to cancel the radian measure, so that needs to be below, and have the degrees above. So we take our basic angle, and then we multiply and divide by 180 over pi. So the pi's cancel. 2 cuts into 180, and the negative in front gives us negative 90 degrees. Likewise for this one here, the measure is in radians, so we need to cancel away the radians and put in the value degrees. So boom, the pi goes away, 3 cuts into 180, leaving us with 60, and then 4 and 60 is 240 degrees. All right, so for the final one here, just to kind of throw a wrench at you, notice that we're using pi, but we use degrees. That's fine. There could be 1 degree, 2 degrees, 3 degrees, 4. Pi is just a number. So careful, just because we have it as a common measure, due to the subdivisions of the circle, pi degrees still make sense. So you have to be careful and stack the right ratio. If degree is in the numerator, we don't want to multiply it like we did in the last 2. we want to have the degrees cancel, so we need to multiply by pi over 180. So the only thing that goes away is the symbol for degrees. Pi times pi is pi squared, and 180 is stuck below, and there is an angle in the radian system. But okay, so with that example, that concludes this lecture video. Hopefully you are all doing well. I'm sure I'll see you soon. Take care.